Hi everyone, and welcome to Migrating C++ to 2019. Today we're going to be looking at practical advice for taking old C++ Builder projects, sometimes very old C++ Builder projects, and updating them to modern C++ Builder. Now we'd really like to encourage you to ask questions in this webinar. The way to do that is to use the Q&A panel, so you can type in a question in that. Hopefully we'll be able to answer some in text during the webinar, but at the end of the webinar there'll be a live Q&A session and we'll go through the questions and actually answer them live. I'm David Millington. I'm the product manager for C++ Builder here at Embarcadero. You can see my email address and Twitter there on screen, and you're always welcome to send me an email. It's fantastic to hear from customers, so please feel free to get in touch with me anytime. So what are we going to look at today? Well, first we'll have a brief look at why you would want to migrate forward, and then we'll have a look at the general migration or upgrade strategy. After that, we'll have a look at a few specifics. So we can look at handling old projects, that's the old project files, and upgrading your projects. Handling dependencies, so the libraries that you use. Handling OWL as one example of a common dependency for very old C++ projects. How to handle the Unicode transition that happened about a decade ago, and then how to upgrade from the classic to the Clang compiler. So there are a few reasons to upgrade. One question you might be asking yourself is whether the old technology that you're using is holding you back. If you use an older IDE, for example, you might have problems running it on newer versions of Windows. You very likely may have problems debugging on newer versions of Windows. You might be missing modern coding tools and libraries. If you want to start using CMake, for example, then you will find having a more modern toolset makes that a lot easier. You might benefit from a newer toolchain in other ways as well. The Clang compiler, for example, has excellent warnings and error messages compared to the classic Borland compiler. Or if you're using old libraries, they might be missing new features or new platform support. If you're aiming at Windows 10 and your libraries are still built with Windows XP in mind, you will be running into problems. Or perhaps the technology you're currently using is holding your software itself back, the software that you create, that you distribute to your users. For example, your software might have problems running on Windows 10, or might have problems handling international file names or other Unicode or internationalization issues. It might be running out of memory and needs more memory space, and so you might be looking at upgrading to 64-bit, which will mean upgrading to a newer toolchain. It might be slow and you want a newer compiler that compiles more performant code. You might find that there are C++ libraries out there that you want to use, but your IDE and toolchain is too old to be able to compile those. Or you might want to write cross-platform applications, and you're stuck on a version of CBuilder that is Windows only, and so you want to move forward. There might be other reasons as well. But all of these add up to quite possibly many reasons for you to upgrade from older versions of C++ Builder to a modern one. So the rest of the webinar is going to be focused on practical advice for how to do exactly that. So before we dig into any specifics, let's look at a general strategy for how to upgrade old projects and old code to a modern version of CBuilder. This is necessarily going to be fairly high level, but I think it'll cover a general sort of approach that will suit well. The technology and the current ID that you're using, which version you're using already, does affect how easy it is to upgrade. So for example, if you're using one of the XE series, let's say XE3 or 4 or 5 to 10.3 Rio, that will be straightforward, really easy. CBuilder 6 from circa 2001, by the time you're starting to talk 17 or 18 years, that is harder. And there are some specific common road bumps. One of them is OWL to VCL, so that is roughly, let's say, mid to late 90s. If you didn't make that transition at that time, that is something that you should consider doing now. And Unicode. Unicode was introduced in CBuilder 2009 in late 2008. And again, if you're on a version from before then, then that is a potential road bump. Now, OWL you don't necessarily have to upgrade. I would recommend that you do, but there are ways around it, and we'll actually cover OWL in one of the sections later. Unicode, however, is a must. We don't support non-Unicode in DollFree or C++ Builder these days, basically because we live in a Unicode world. So that is something that you will need to tackle if you're still using a version of C++ Builder from before 2009. There are some other sort of smaller potential road bumps, such as anytime you want to migrate from 32 to 64-bit. We won't focus on that today. There's lots of other material online that's widely applicable, and it's really quite straightforward, or at least the issues that you'll encounter are very easy to categorize and are well known. Or there's the project format changes. For example, we changed to using an MS Build based project format in about 2007. Or if you want to move cross-platform. Now, moving cross-platform from Windows to FireMonkey, that specific move is not something that we're going to cover today. We'll cover a migration that you might need to do to get up to 10.3 Rio in order to use FireMonkey. But moving your application to FireMonkey is something else that, again, there's a lot of material online already. In general, the strategy depends on how far back you're upgrading from, but very broadly, I would recommend creating a new project in 10.3, install your third-party libraries or new versions of your third-party libraries, and then tackle the various significant issues, things like OWL or Unicode. Now, the goal is to get a building app. So when you have a large code base and you may have several issues, for example, let's suppose that you have an app that uses OWL for its user interface instead of VCL, and it's pre-Unicode, and you're going all the way up to 10.3 Rio, you have two significant items there. Well, the best way to approach that is to do it one by one. Don't try to do two big things in parallel. Have a plan for how you're going to do it and tackle each one of these issues on its own. And then when you add those together, you'll be fully migrated. The goal is to get a building app, and that means that you want to get a building app by whatever means necessary. Once you have something building, you can start adding things back in. So when you upgrade, start doing everything you can just to get a building. You know, comment code out, remove code, whatever you need to do, as long as you can get something where you press the run button, will compile and link. Of course, when it actually runs, you may run into problems, but that's the kind of thing you can fix. Your aim is to get something that builds, and then once you have something that builds and that you can debug, you can start adding in all the things that or start undoing all the things that you did to get the app just at that building state. And of course, once you have it building, once you have it running, you can test it and then resolve issues. That's a rough approach. Create a project in 10.3, tackle one issue at a time, and then when you're doing that, just get the app to a building state. And then you build, you find your issues, you fix them, you repeat them, you go back to whatever modifications you had to make to get it building, whether that's tearing out a library and just replacing it with stubs or anything like that, where you might want to then put that back in. And just repeat that process of sort of reaccumulating the app back together. So let's have a look at upgrading the old project files. If you have a really old version of C++ Builder, then you might have a BPR file, for example, or something similar. Now that's too old to open in modern C++ Builder. And in fact, we do occasionally get support requests where people are trying to open these very reasonably, since it was made by C++ Builder, just a very old version. And the answer is simply that those format project files are no longer supported. And the best thing to do there is not try to open it, just create a brand new project and add the existing files. If you're upgrading from a newer version of C++ Builder, a version that uses the MS Build project format, then the MS Build file, that's .cbproj, can be upgraded. So we have code in the IDE so that every release, such as 10.2 to 10.3, when you open a project, it will make some changes to that project file to account for anything that's changed in that release. When you open a very old version, of a project file, it has to do that for a large variety of changes, and that can cause issues. So when you're upgrading such a long distance, then again, I would recommend don't try to open it and update it. Instead, create a brand new project file and just add the files. And there's a bit of a theme here, that in all situations, it turns out there's a dot point saying, don't open it, where it is your old project file. Don't open it, create a new project, and add files. So here's the best way to do it. First of all, just create a new VCL application and save it. And one thing to note here is that you may want to turn on the classic compiler. So in 10.3, when you create a brand new Win32 VCL application, it uses the Clang compiler by default. And in terms of changing having as few moving parts as possible, when you're upgrading, you will probably want to first use the classic compiler rather than trying to do a classic to Clang change as well as migrating and upgrading. Although we will actually cover moving from classic to Clang in a few minutes. So create a brand new VCL project and change the compiler settings from the Clang compiler to the classic compiler. That's in the project options C++ compiler. Now a brand new VCL application will have one form, and so you should remove that. So now you have a very empty application. You have a project and a CPP file, that's your main CPP file, and that's it. It's a very empty app. At this point, I would edit any project options that you want to, things like include paths, obvious candidates. One thing I would recommend though is to try to leave as many compiler options at default as you can, unless you have a very good reason. This is mainly so that it will make it easier to upgrade from classic to Clang, but also that you really want to keep as close to the default settings, usually, as you can. And projects that have changed and mutated over many years may have had many changes added, and if you can, you should probably assess those in your old version of C++ Builder and see which ones you can rule out. Or if you don't want to do that, just try straight away not changing any settings and seeing what happens. You can keep settings in mind if you run into any issues later as a potential reason or thing to change to resolve issues. So at this point you have a brand new, very empty application, and just add your old C++ files. And this is really simple, simply because you can just drag and drop from Explorer. So you'll have a folder or multiple folders of source, and you can simply select those files and drag and drop them right into the project manager. At this point, you have a new and clean project, and you have your existing source. And this is the point at which you should try building. Now, you shouldn't expect it to successfully compile. That would be fantastic, but unlikely. But you can start fixing errors. So you may run into errors where it can't find a particular file that it's expecting, so you might need to set up the include paths. You might find syntax errors. That's unlikely if you're moving from the classic compiler to a new version of the classic compiler. That's definitely unlikely. It's more likely if you're moving to the Clang compiler, because the Clang compiler is a little stricter on its C++ code. We address that in a couple of sections in a few minutes. One thing that is far more likely is that you'll have missing libraries. So we'll have a look at that now. And of course, there can be other more severe issues like Unicode, and we'll examine that in a few minutes as well. But by the time you've done this, you've already made significant progress. So, you have a project in 10.3. It has all your source there. You just need to get it working, and that's a good first step. So let's move on to discussing how to handle missing dependencies. And again, this is going to be a fairly high-level approach because the actual approach that you take will depend very specifically on every library that you have. But the goal here will be to categorize the dependencies and libraries into a couple of different categories and give advice on how to tackle each particular type. Our current situation in our migration project is that we have a new clean project in 10.3 with your existing source, but you can't compile because you get some kind of error indicating that a library is missing. Perhaps it's missing the header file or something like that. There are two general types of libraries you'll be using. One's written in C++ or one's in DollFree, and sometimes there'll be a third, ActiveX libraries. In general, of course, what you want to do is try to find new versions of each of them, but the strategy depends on what kind of library you have. So in general, when you have a missing C++ or DollFree library, the normal steps that I'm sure you already expect to follow are to Google and identify the manufacturer and find a new version and buy it. And that seems straightforward. If you do that, then you can find a new version of the library and use it. Now, depending on the sort of time distance, the number of versions, that kind of thing, between the old version of the library and the new version, you may still have work to do, but it will be fairly straightforward. You'll usually find that a library will have generally the same API, the same interface. Things might have changed a bit, but in general, library vendors don't rewrite the way you interact with the library wholesale every version. You might find that you need to make tweaks or changes, but once you have a new version of the library, in general, you should be able to add it to your project and take straightforward steps to get it to compile, or at least get your code to recognize the library, to call the same methods, that kind of thing. What happens though if you can't find a new version? Well, the first question to ask is, do you have the source? And if yes, then regard this as an upgrade project of its own. Now, one of the sort of general strategic principles that I mentioned at the beginning of this was to try and only do one thing at once. So that means that if you're going to upgrade the library that you have as a project of its own, then do it genuinely as a project of its own. In other words, pause this current upgrade project and go and do that. If you don't have the source and you can't find a new version, then you're going to need to replace the library. It is not technically possible to use some very old versions of libraries with a new version of CBuilder. There are some situations in which that may work. That would be when you have a DLL and you have a flat C interface, for example, and in that case, you'll have a header, and you can continue to use that. But that will limit you as well to remaining 32-bit windows for the application. So let's assume, just for following this particular scenario, that you need to replace the library. So once again, don't try to do too much work at once, because upgrading multiple projects at once is hard. My personal recommendation for how to do this is just to create the headers and possibly C++ files with stub empty definitions for each compile error you get. So first of all, fix the ones where it can't find an include file by making that file. Then you'll get a bunch of compile errors where it's saying, I'm trying to call method foo and method foo doesn't exist. So write an empty, completely empty method foo. And you do this because it will let you compile, it will let you build, and then once you're building, you can go and replace it. It is really important to get to a stage where you can build, even if the app isn't functional, because building is a powerful step, it's a powerful stage to be at. So once you can build, you can then figure out how to actually handle the library. You might have found a new library that does the same thing. Now you might go through and replace everywhere in your code that calls the old library. So all the places where you wrote a header file and you created the empty stub methods or type definitions or something like that, you would now remove all that, find all those compile errors again, and use that as locations to write new code. Or another approach is that because you wrote a stub header and it was enough, it had all the methods that you use and all the type definitions that you use and so forth, it was enough to compile, then you could use that to write a wrapper, because that means that you know the API your code uses now. So you have enough for your application to build, and you can use that to write a wrapper around the new library. And the choice of which one of these to do is up to you. Writing a wrapper may be faster, because you don't need to change your code logic or structure. On the other hand, it does add another layer. You may want to be more thorough and replace the library entirely. It's completely up to you. I think both these methods are fine, about 50-50. Simply evaluate them for your own project. The one thing where this gets a little more complicated is when you have UI components, such as a visual component that you might use in the VCL form designer. And of course, if you can upgrade those are that's definitely the option to take. And for visual components, the interface is usually extremely stable. So most likely you should be able to install the new version of the component and it should work. If it doesn't, then the vendor, of course, can assist there. And it's always worth remembering that you can edit a form file, the DFM file, as text. You can do that right from within the IDE by right-clicking and choosing to edit as text. That can be useful just for tweaking any particular things that may have changed, but in the vast majority of cases for a visual component, you won't have to. The other thing you can do is that if you have a UI component and you can't find a new version and you don't have the source, then you need to progress to the stage of being able to build your application without damaging your UI. Now, if you open a form in the IDE and it can't find a component, it will offer to remove the definitions, and that's most likely not what you want right at the moment. Now, you can do that because the event handlers, the actual code and so forth will remain there, and you can look at that code and review what it did in order to to replace it with a different component in the future. But if you want your UI to remain there even though non-functional, you might want to say a blank rectangle where the old visual component, whatever it was, used to be, then you can create a dummy component. So rather like with a library where you might create a header or headers and some C++ files with stub or empty definitions, you can do the same with a component. Just create a new one descending from tcomponent or twincontrol or whatever's appropriate. Add in the properties and methods, but make them do absolutely nothing. And then you can use that to get your application building. Once again, once your app is building, and I say working on screen, but obviously this is working for a certain definition of working. Once your app is building and you have it functional enough that you can start revising, then you can work on replacing the components. Here's something more specific. You have a missing C++ library. So for C++, you're far more likely to find an open source version or an open source equivalent. So that is where I would first look. If it's in C++, you may well have source. Of course, if it's compiled, you might not. And we refer back to the previous slide for how to approach that. But if you do have source, then often it's simple as rebuilding. And you may want to regard it as an upgrade project on its own. If, for example, it needs to be moved to support Unicode, then again, I just pause at this point, take that library as its own project, migrate that to support Unicode, and then return here and start using it. Many libraries, like Boost, exist today, so you might not have trouble finding a newer version, and in fact growing. And older libraries like TR1 actually moved into the standard. So TR1 moved into the standard in C++11. And so the way to handle libraries like Boost or TR1 is simply to keep your code. So for Boost, that's fantastic. You can just use a current version of Boost. For TR1, you only need to make fairly minimal code changes. With a caveat there that you should use the Clang compiler because that's what's required for C++11 and newer. So TR1 is a great example because many people use it for good reasons. And generally, you just replace std : tr1 : with std and include the right header. The interfaces are usually very similar. For example, weak pointer requires you include the memory header, and it's std weak pointer. So in general, conversion there is straightforward. It's just a matter of using the new headers and massaging the code a bit, and you'll be fine. Another issue, you have a missing DollFree library. Well, again, the first question is, do you have source? And this assumes, by the way, that you haven't found a new version. If you found a new version, fantastic, install that and continue. But if you haven't, do you have source? Because if you only have the DCUs or the package, the BPL, then you need a new version. If you do have source, then upgrading itself is a possibility. And as a bit of a word of advice, possibly 10 or 15 years too late, but advice now is always better than any other time. If you can, always buy a library with source, because it gives you a fallback. It gives you something you can rely on. You don't end up trapped with a particular version because you only have binary code that will only work with a specific version. Now, there may well be a new version available from the manufacturer, which is fantastic. It might have been open sourced, which is fantastic. Many common DollFree libraries from 10 to 20 years ago are legally online. Many of them are even in Get It in our package manager, so I would recommend having a look in that. That's in the Tools menu, go to Get a Package Manager, you can search it. All the TurboPower components, for example, open source and in Get It. Tori.net still exists and has many. And of course, other people will have used the same libraries that you did, so you can ask online. And there's a link on screen to our online forum. The specific link here is to a forum for third-party libraries. The third scenario is when you have a missing ActiveX library. Now, in general, you can simply import that again in 10.3 Rio. So for any common type library, ActiveX .NET Assembly as well, use import component, and there's a link on screen to the help page for that. But as well, find the current owner, because many ActiveX libraries were written for multiple programming languages. They could be used from Visual Basic, as well as from DollFree, as well as from Visual Studio. And they may have changed hands over the past 20 years. I can think of several that I know existed back in 2002, for example, and still exist today, even though they've been sold to a different company. So work on finding the current owner. Most likely they still exist and still have an up-to-date version. And then, of course, you can treat it like any other library. You might import it into RAD-Studio, but then moving to it, again, it's likely that it has a fairly stable interface and that changing your code to use it is fairly straightforward. So let's look at one specific library, OWL. Now, if your reaction to this is, what on earth is OWL? That's great. This is mostly going to be useful for people with code bases that extend back into the mid or early 90s. OWL stands for the Object Windows Library, and it was the precursor to the VCL. It was a Windows control library. And OWL in general is outdated, obviously because of the age, but also because of the code structure, the way it worked. The VCL introduced a really nice way to interact with controls, including specializing controls. When you think of it, when you're adding a button to a form and changing its text, its caption to say OK, you're specializing it. In VCL, that's a lot cleaner than in OWL. So in general, the recommendation is to replace it, and you do that with either the VCL or FMX. But for migrating a project, you want to do one thing at a time. So most likely what you want to do is get OWL working with 10.3. And the way to do this is via a wonderful open source project called OWL Next. There's a link on screen there to the OWL Next code on SourceForge. Now, OWL Next works as a bunch of patches, so it requires that you have the OWL source. OWL was never open sourced. So the open source project works by having an open source set of patches. It doesn't actually open source OWL itself. So what it requires is that you have the OWL source, which you do if you're already using it, and you apply patches to it. And it works on modern compilers and on modern versions of Windows as well. And it's really impressive. So that's my recommendation there. When you're migrating, simply use OWL Next, and that should be the approach to migrating your UE first. Once you've done that, as a separate project, you can start converting that to the VCL or FireMonkey. Now, one neat thing is that you can interop between OWL and the VCL reasonably easily because they're both wrappers around the Windows API. So for window parenting, for example, you can set the parent window in VCL or use the applications handle or the main forms handle, for example, for OWL. Now, you wouldn't necessarily want to mix controls on the one window, but if you're doing something like showing a modal dialog, then you can certainly interop there very straightforwardly. And then long-term consider replacing OWL and rebuilding your UI. So that was a really short section, only one slide. Let's move on to Unicode, which is more complicated. So in C++ Builder 2007 and earlier, C++ Builder used ANSI strings. In C Builder 2009 and newer, including the current version, it uses Unicode strings. Now, when we say that 2007 versus 2009 was ANSI versus Unicode, what we're actually referring to is the VCL and the DollFree RTL. So the UI layer, the VCL changed. It is what is only Unicode. C++ strings such as std_string and wstring remain exactly the same. You can use wstring in an old version of C++ Builder if you wish. But it's the UI layer, the DollFree side, that changed. So DollFree string was ANSI string, and now it's Unicode string. And what this means is that all code that interacts with the UI needs to be modified. So presumably if you're using the VCL, then you'll have event handlers, for example, properties that you read and write, that kind of thing. They're all strings, and they were ANSI and are now Unicode. And you will need to change your code to account for that. Now, when people hear this, one very common and very reasonable response to hearing that it's at the UI layer, it's at the VCL that this will most likely affect you, unless you use a lot of the DollFree runtime library methods. But for the majority of people, this will only be at the UI layer. A very reasonable response is to tackle this only by modifying the string code that directly interops with the UI. Logic being something along the lines of, if I do that, then I can leave the rest of my working app alone. And that seems very reasonable. But I'd like to suggest that this is the wrong way to do it. It really is. It's something that appears reasonable, but will cause more issues than it solves. There are a couple of things. The first is you'll end up with conversions everywhere. So a huge amount of code will need to be wrapped in conversion to and from Unicode. So a whole bunch of your UI methods, perhaps, depending on how well structured your UI and logic separation is, at some point there's going to be handover. Everywhere that you interact with a string then will need to have a conversion added. And that'll be some kind of method. And you'll have to manually go and add that method in every single place. And that is probably more code than you may have realized. And you'll be modifying every single interaction. Another thing is that you will get potential data loss at every UI into code transition, because your UI will handle Unicode just fine. And that means that people can type in using all sorts of characters. People will be able to open files with interesting file names. But when you convert those, that conversion is lossy. And so you may have a number of dangerous bugs appear, bugs that you may not even find initially through that transition, that conversion, and the data loss that's involved there. Another thing is that your code will be slower because conversion is expensive. Windows right now runs as Unicode under the hood. When you use the ANSI functions, it has to convert. And what you're doing is you'll be adding multiple layers of that. So your UI will be in Unicode, and you'll be converting to ANSI internally, and then you'll be converting from ANSI back to Unicode for your UI, and you'll just have so many conversions. Now, it may not be a huge performance impact, but it's worth being aware that Windows is Unicode native, and that any conversions that you force your app to do will have a slight cost. And your code will be messy. You'll be constantly switching string types as well as having all those conversion methods everywhere. So I strongly suggest that the best thing to do is just to make it right up front. That is, to Unicode convert your entire app. The only reason to stay with ANSI is if you deliberately need to use it. An example is for serial port communications. You might be communicating over a serial port or over some other interface to something that expects characters to be of byte length. And if that's the case, then that shouldn't control your whole application. You should just wrap at that layer. That particular part of your code obviously should remain using byte length strings. But the rest of your application, all the normal string interaction should be converted to Unicode. And this will mean that you don't have any conversions, or if you do, the conversions are going to be very localized. Now, if you've used only the DollFree string types, then there's very little work there because string is just now Unicode. You may have issues where a character, such as car with a capital C or lowercase c, is assumed to be 1 byte. For example, string might have been used as an array of bytes. Now, a string is not an array of bytes, and it shouldn't be used as one. And if you've done that kind of thing, it's good to rework that code to use some other data structure. That's a lot less likely in C++, but you may still have some code that makes those kind of assumptions. The other thing you should do is you should change the project options tcar maps to setting to the wide character type. Now, if you mix DollFree and C++ strings, which is quite possible since C++ has string types, then you'll have little more work. General advice is change all your usages of std_string to std_w_string. You can do that via search replace, and note there are a few other things that you'll need to replace at the same time, such as using std_w_cout, not cout, or things like that. Now that's generally straightforward. I mean, it depends on the size of your code base, and there might be a lot of search and replace here, but that is straightforward. It gets a little more complicated with string constants, because you'll have a constant wrapped in quote characters, and you'll need to attach a prefix to that to specify the type of string. Now, if you're converting wholly to Unicode, you can use the L prefix, for example, but you will need to do that. And I'd recommend using a Python script or something similar to assist you there, because searching for quotes is a little more difficult. It will return far more results. You might have pointers, so you might have a car pointer or a wcar_t pointer, so you'll change a car pointer to a wcar_t pointer. But you'll need to be careful there, keep a close eye when you search replace, because you want to change pointers that you use as strings, pointers to string data, but not data pointers. One of the problems with C++ is that it doesn't really, or at least in the past, it hasn't distinguished well between a character and a byte. Now these days there are byte types. There's a std byte. You might want to consider converting to use that as well, so that anyone reading your code will immediately know whether something is genuinely a character or a byte that's being interacted with. Once you've done this, you'll most likely already have code that converts between std_string and what was ANSI string, string that was ANSI string. Now you can do the same between Unicode string and std_w_string. For example, using cstr and converting between the two string types like that. Now it is worth noting that a W string and a Unicode string don't necessarily have only one character at a particular index. Because of the way Unicode works, there are all sorts of modifiers and complications. But in terms of converting between the two types, you can simply convert the same way that you did between the narrow types as you can between the wide types. You should keep an eye on any code that iterates through a string character by character, just in case there's any code that might be confused by modifiers or something like that. But that's fairly rare. When it comes to file I/O, if you have your own file format, and you're loading and saving to that, you'll most likely have string data in that. The best approach here is to increment your version number and have a new version of your file format. And this is a great example of isolating ANSI code. So to convert your entire app, but only have the necessary bits ANSI, where the previous example was interacting with some kind of serial device, for example. File.io is a great example as well. So you would have code that loads your old format, and that would remain as ANSI, loading ANSI, but it would convert. It would convert to Unicode. And the current version of your file loading and saving code would be wholly Unicode. So your app should now load and save to Unicode, but of course you can load your old file format. The key there being that it converts. So your whole app is Unicode, and it's only the file, like the legacy, the old version file loading code that performs the conversion. That means it only happens once when someone opens a file. Here are a few sort of random useful notes. ANSI string today can carry a code page. That's really useful for attaching code page to any particular ANSI text. And for example, if you have a CBuilder app that was written to work in Russia, then you should make use of that to associate a code page. And that will really help when converting between ANSI and Unicode. If you have UTF-8 data, then use UTF-8 string. There are many conversion routines, so do use them. You don't need to write your own ANSI to Unicode conversion. We have all that code already. It's solid, robust, and works, so make use of it. For example, look at the T encoding class as some great conversion routines. Now, converting Unicode to narrow is lossy, so that's the main reason to always Unicodify your app and upgrade your data to Unicode and keep it Unicode. And finally, there's a great webinar on this that Al Manarino did. There's a link on screen. It's called Migrating Your C++ Builder Projects to Unicode. And this covers all of this in far more detail. It's important to remember that all of this is doable. Many people have done it before. I've done it before. It's quite common. Everyone, almost every programmer in the world who has started with a code base that was written, say in the 90s at least, but maybe even the first half of the 2000s, has had to tackle this problem. You can do a lot with search and replace. Python scripts would definitely help for, it doesn't definitely have to be Python, I just think Python is nice. Might help for identifying things like string constants where you want to add a prefix. And again, the key is to replace, to build, to find mistakes, to fix, to build again, repeat until you get a building up. And I really, truly, speaking from experience here, I know it's very tempting, but I strongly recommend not to try keeping some parts ANSI and some Unicode. Convert the entire app. Only use ANSI for things where it really makes sense, where ANSI is genuinely required. And do so by using ANSI strings in that particular area and converting immediately so that your entire application works in Unicode. It just has this one little bit where it speaks ANSI strings. Finally, for the main segment on migration, let's have a quick look at moving from the classic to the Clang compiler. Now, this is something that you will want to do if you want to write a 64-bit app. Even if you happen to still use the classic compiler for Win32, then you need to use the Clang compiler for Win64. But you may also want to upgrade from the classic compiler to the Clang compiler on Win32 as well, because of course Clang is in general a better compiler, especially the compiled code that it creates in the error and warning messages. So one thing I would suggest is that regardless of your reasons for doing this, whether you're aiming at Win64 or whether you're just wanting to convert anyway, the best thing to do is to convert to Clang on Win32 first. And the reason for this is that you iron out any classic to Clang issues. Then you add 64-bit. Migrating between 32 and 64-bit is its own step. So convert to Clang first, and then add 64-bit. And if you've upgraded to a recent C++ builder, then moving to Clang is highly recommended. Clang is the future, and our Clang-enhanced compilers are the future of C++ builder. So the classic compiler is classic. You could consider it legacy. We do still bug fix it, for example. A few months ago, we made some great changes in exception handling, but in general, the vast majority of our development effort is on the Clang side. Clang supports newer C++, and that's better for you as well. It's more elegant code, it's safer code, it's smaller code, your app gives better compile performance and all that kind of thing. Also gives better error messages, and that's hugely useful, it really is. And we really strongly do recommend regarding Clang as the future and planning to migrate to the Clang compiler. So to convert from Classic to Clang, the first thing to do is toggle the setting in the project options. And that's straightforward. Rebuild. Now, you may run into some compile errors. It strongly depends on your code and the methods that you use. The Clang compiler is a little stricter on some C++, and the C++ standard is very precise. The classic compiler was a little more relaxed on some things, on its interpretation of some things. And so if you have code that accidentally worked with the classic compiler, and accidentally is a real term because the classic compiler obviously meant to abide by the C++ standard as well. It just happened to be a little more relaxed. If you have some code that happened to work with the classic compiler, it may need to be tweaked to work with the Clang compiler. But these will not be large tweaks. The error messages will be clear, and you'll be able to figure out what needs to be changed easily. The most common issues that you'll run into, especially if you tried in older versions of C++ Builder before 10.3, would be to do with the runtime library, such as missing math methods or other RTL methods. Now in 10.3 Rio, we've done a lot of work here, so it should be a lot smoother than it was. And we have some good documentation here. You can see the documentation on the screen. The main page to look up is the one on the Clang Enhanced C++ compilers. It contains a lot of info itself, and it's sort of an index page. There are some subpages, such as the options, compiler options, that aren't supported by the Clang Enhanced compilers that you should read as well. And if you're approaching this, I'd recommend to read and familiarize yourself with all of that documentation first. Then when you actually go and toggle the setting and you build, and perhaps you'll find something that doesn't compile, you'll be ready for it. You'll already know what to do. And in general, this is straightforward. So I myself have converted some large projects to the Clang compiler, projects that didn't compile straight away. And it's really just a matter of building and finding compile error and fixing it. It's usually fairly obvious what it is, and building again. It's rote work, like it's not even necessarily particularly exciting because you're just fixing compile errors, but it's straightforward, and it shouldn't really take you too long. So there we are. Let's have a review of everything that we've covered today. So we looked at 7 things. We looked at reasons to migrate forward. We looked at the general strategy and approach to have. We looked at how to handle the old project files that you might want to upgrade, how to handle dependencies and libraries, a couple of specifics such as handling OWL and Unicode, and then classic Clang, briefly touching on 32 to 64-bit. Some questions that you might have might be around the time investment. How much time or how difficult do some of these things take? So in terms of the old projects, simply taking an old project file and creating a new 10.3 C++ Builder project, I really think an hour or less. And the reason for that is that you don't want to upgrade it, you just want to create a new one. So create a new one and just drag and drop your files from Explorer straight into it in the project manager. That doesn't take so long. For dependencies, that's far more difficult to answer, and obviously for any project you should probably try and estimate this yourself. If there are new versions available, then obviously there's the time it takes to buy them. The interface is likely similar. So again, obviously this really depends on your project, but a couple of days each, perhaps. If you're upgrading from source, then you need to estimate each by itself. Now you would regard each as its own upgrade project, and from that you'll have a lot of familiarity with the code. From that familiarity, I think it's likely that once you've upgraded each dependency, it won't take long. If you're replacing it completely, if you take the approach of mocking an old interface, just getting your application building for every compile error, every missing method, every missing type, just defining it in the header somewhere. Again, it hugely depends on the size of your project. That might take you an hour, it might take you a few days. Now, to replace it, do you want to write a wrapper? Do you want to completely replace it? Again, it's really hard to put a number here because it's specific to every project. But let's assume it takes something like a week to replace. In terms of OWL, to use OWL next, a day, it's really just a set of patches. You can apply that to the code you already have, and then you'll have a version of OWL next that should work. To replace, and by replacing here I mean rewriting to use the VCL or FireMonkey. I'd estimate 2 or 3 days for a normal complexity window, but of course, what is a normal complexity window? If you have an options dialog with 100 different tabs, that will obviously take a while. What I mean here is just a dialog that maybe has a couple of tab items and a few buttons and edit fields and that kind of thing. You would rebuild it in VCL. You would look at the old code that used OWL, and you would move the code over into the new FMX or VCL event handlers and that kind of thing. It might take you a couple of days the first time, especially because you have to get used to the VCL or FireMonkey if you haven't used them before. That would speed up as you replace more, and I think you would find that as you keep on replacing, it'll become shorter and shorter. There is one thing there with OWL, that the application and document classes have no exact replacement in the VCL. So one thing you may need to do there is to write your own. And for that, I would take the approach of having stub methods and then just filling them out. The OWL applications that I know of that interact with the application and document OWL classes didn't use all of their methods. And simply creating some stub ones and then filling them out so you have some classes that perform that kind of logic is a very reasonable way to go. And that could take you a few days, I think. The application document classes are pretty simple. Their action is fairly simple. The most complex thing is how do you implement that in the VCL. Now for Unicode, this can be more complex simply because there's a lot of code that you need to actually modify. You'll need to change the string types. You'll need to change string constants. You'll need to verify that each bit of your code that uses a char pointer is actually using and referring to strings, not to data, and so forth. You might have to add file I/O, all the kind of things that we talked about a few minutes ago. Now here's a really rough estimate, which is that per million lines per person. So for 1 million lines for one person, you might take 4 weeks, maybe 6 weeks for very complicated code. For 2 developers, 3 weeks. This is completely ballpark. You may find it much less, but I've tried to give an estimate on what I personally think is on the higher side here. It's very reasonable. You look at these numbers, and these are the same kind of numbers, or even smaller perhaps, than you might have for some other project or feature. So it is definitely very doable. Now for classic reclaim, now possibly it's just a recompile, but of course in practice, that may not be the case. We do try and assist in making that the case every release, and especially in 10.3, we added a lot of RTL improvements. So that issues you may have run into in the past, you hopefully won't run into today. But realistically speaking, there's always going to be issues. Now, if you have issues, and let's assume these are fairly complex issues, there's a reasonable amount of code that, for whatever reason, just isn't valid C++ these days. Per million lines for one person, a couple of weeks, I think. Again, this strongly depends. I remember looking at some code, for example, where the class used a double ampersand for its parameters. So if you'd have a method parameter and it was, let's say, an int ampersand ampersand, that was compiling fine using the classic compiler, but of course with the Clang compiler that has a different meaning. And you need to catch that kind of thing and decide what it was meant to do, and ensure that it works correctly. But in general, it's really just a matter of compiling and fixing compile errors and compiling again. And that can be rote work, but it's usually not that complicated, because when you have a compile error, we all know how to fix compile errors. You just go ahead and figure out what's wrong with the code and modify it. So it's very reasonable, and I think one person for a million lines of a couple of weeks is a reasonable estimate. Noting, of course, with caveats that it really hugely depends on the code. In terms of overall advice, I think the best thing to keep in mind is that many people have done it before you have, and done it successfully. And the problems you run into, they will have run into, and they'll be online. I would advise, and this sounds like obvious advice, except that once you get deep into a project, it can be easy to lose sight of this. I do advise to plan step by step and try to do one thing at a time. When you're deep into converting something and you find something else that needs to be worked on, you find a library that you need to replace or something like that, it can be easy to try and do all of that at once. So you just add all these things together and it becomes this enormous task. Whereas in reality, it's not an enormous task if it's broken down. So I strongly would recommend try to do just one thing at a time. And in general, just aim to get your application building. That's the first goal, and you can take any approach to that you need and do anything you need to your code to get it building. You can remove vast amounts of code and comment it out, and write stub methods and all that kind of thing, as long as you get a building application. Because once you've done that, you can then go back and revisit everything that you did to get it there. And that will be, you'll have done that, and you'll know what changes you made, and you'll have a set of things that you need to go and change and fix. And that's a nice place to be at, because you'll have a roadmap. You'll have a set of things that you need to do. I also recommend starting with a new project and adding files to it. Don't even try to upgrade the project files if you're going from a really old version to a modern one. Just start with a new project, make completely empty, add your existing source. And the last dot point here, sort of covered a little already, but it says don't mix and match. That can be taken a few ways. Unicode is a good example where I do recommend just converting the entire app to Unicode rather than going half and half. What I mentioned earlier was to tackle Unicode as one thing, only Unicode, rather than doing Unicode plus libraries in one go. Fixing multiple items in serial is a lot easier than multiple items in parallel, and changing something wholly rather than adding layers of conversions is a better approach. Now, overall, we have excellent backwards compatibility. We're talking upgrading projects here that could be built on 20-plus-year-old technology. And this is significantly easier with CBuilder than it is with other tools. It really is. So for that reason as well, don't be intimidated. Just dig in and keep coding. And just keep on coding and you will get it building. And the talk today has necessarily been high level. It's been fairly long in spite of that, but it has been high level, mostly just slides. But it does contain concrete advice that I do personally recommend from experience. And if I want to leave you with one thing, it's the bold top point at the bottom, which is just to plan it step by step, one thing at once, and get it building first. Once it's building, then you can revisit and fix. And this migration effort is well worth it. You get the modern compilers, you get nicer code and safer code, you get faster apps, you get modern RTL and libraries, you get something that runs better on modern operating systems, you get a more productive IDE, all of those kind of things, all the wonderful C++ 11 and 14 and 17 code, for example, code that really makes your app more stable and where you end up writing shorter, more succinct, more elegant code. As a developer, you may want to upgrade just for that, but there are so many other advantages. And depending on how far back you are, then this might be a big leap. We've touched on things here that might involve upgrading code from way back from 1994, for example. And that is a big leap, it's a long time. But once you do it, then staying up to date afterwards is easy. There are very few changes that significantly impact upgrading release to release. The difficulty is over the large amount of time. So once you've done it, then you'll be on a modern version of C++ Builder, and then you can just move to the next version and the next version and the next version every year as we release. If you have update subscription, then you get each version. And that change going version to version is incredibly straightforward, and that's the best path really to jump forward and then to be able to stay up to date and stay current. You don't want to end back bang with the same problems that you have now in 5 years or 10 years, and that's really not a good business decision. You want to stay up to date always. And at this point, we'll move over to the Q&A. So don't forget that you can type questions into GoToWebinar, and please do. We'll be answering those. Meanwhile, while you do that, there are a few resources on screen. I made a short link here to the Clang compiler documentation. And one thing to point out there is that at the bottom of that particular page, there's a topics section linking to about 10 other pages that are all worth reading as well. A couple of things on converting to Unicode. These are YouTube talks. The top one there is Al Manarino's excellent talk. And then there's a smaller talk that I gave that might be interesting, which is just on C++ string types. If you're not hugely familiar with that, on the different types of strings you can have in C++, I think that's good background information to have. For Al, there's a link there to the SourceForge repository, and a few sort of general links, youtube.com/user/Embarcadero TechNet, that's us. I looked today, this is the 5th of March when I'm recording this. We have 1,572 videos on that. We have a vast amount of material there, and it's all really good material. And so search through that for things like Unicode and migration and that kind of thing. And also our developer forums at community.idero.com. Feel free to join those and ask questions. And so with that, thanks very much, and we will now hand over to the live Q&A. All right, well, thank you, everyone. I hope that presentation was useful. And I'll just ask Jim as well. Jim McKeith is on the line. If right now I'm just seeing a black screen, so I wondered if you can just move the recorded video back a second or so, just so those links stay. Hi, everyone. Kelly, and I believe Al Manarino is with us as well.
Does not let me do that, sorry.
So thank you for those guys for attending, and yeah, if you can answer questions as well, that'd be fantastic. And we had a huge number of questions coming in, and we tried to answer as many of those as possible during the talk. So I'm going to go through some of those. I'm afraid I simply can't go through all of the ones that were asked simply from the quantity, but hopefully you can see those answers in the Q&A panel. So we'll go through as many as we can, though. There was just a question here. We're talking about why upgrading. One reason that we didn't mention actually is that old libraries might be missing security and bug fixes, which is an excellent point. So yeah, there are many reasons why you would want to upgrade to modern tooling, modern libraries, and that kind of thing. Now, there's a question here about getting support for Boost in 10.3. Which is an excellent question, first of all, because many people need it in general, and second, because in this talk I actually recommended using the new version of Boost if you're already using Boost. So we've actually been aiming to get it out for a while now. Now, I don't particularly want to give a date since it's already later than we'd hoped, but I'm very hopeful it'll be very soon. I shared a meeting on this earlier today, and I saw some really good progress. So please don't quote me on this. This is not an official statement, but I'd be very surprised if it wasn't this month. And obviously we'd certainly hope to get it out earlier than that. And for future versions, if you're listening to this in the future, ideally we'll have Boost out at the time that we actually have a release. That's certainly going to be the aim for 10.3.2 and newer. There's some comments here about using OWL next for OWL, saying that it works well, which is fantastic. It's good to hear. And let's see. A comment here as well about I was talking about getting an application building. So yeah, I really do strongly recommend, as I think I've said several times, trying to get an app to a state where it builds and it compiles, even if it obviously doesn't work when you run it. Being in a state where actually building is a powerful place to be, because then you can go back and actually fix and change the things that you did. Comment was though that I mentioned commenting code, and I should have added a third word, commenting code out, which is very true. The idea there being that just to get it to a building state, you might want to comment large amounts of code out. It's a good point. I missed that word. It's quite possibly not the only place where I misspeak, but I trust it was understandable. Several questions about if there's going to be a replay and also about slides. Jim, would you like to cover that?
The link to the slides is in the chat window along with the links from it, so you can get those there. Sorry, it's rather noisy on background here. I'm not in my office because of the cleaning. I hope to have a replay up on YouTube. If not, you can get access to the replay through GoToWebinar.
Fantastic. Thanks, Jim. And Mary, I know you're online as well, so if there are any questions here that you want to answer, or that you think I'm not doing a good job of answering, please chime in and interrupt.
Oh, I definitely will. Thanks, David.
Fantastic. There's a question about an easy replacement for the C4 sockets in 10.3, something other than the Indy controls. Well, apart from Indy, I know there are some fairly generic C++ socket libraries that you can look into that are open source that you can find online. We do also have the system.win.socketcomp sockets, although those are Windows only, and those would be worth looking into. There's a question about when it would make sense to download an earlier version, such as one that's old enough to get the BPR file to open. So you could, although if you're upgrading an old project, most likely if you're actively developing that, then you'll have that old version already. If you're trying to resurrect an old project though, then you might not have that version already installed. But the main reason to do that would be to get the file list that's in the project. There's not much other value there. Possibly you might want it there so that you can sort of build successfully and debug and track through how the code behavior works in the old version to compare to the new version. But I think the main value would just be to get the file list of what's in each project. Hopefully though, and I mean really this strongly depends on your file layout, and there's another question about this. Hopefully, when you have the source, you'll know what's in each project, and you can just drag drop from particular folders or something like that to the new projects. And a BPR file, by the way, is just openable in Notepad. It's just a text file. So if that information isn't clear, if it's actually if you have all your source files just in one folder, for example, in multiple projects, and you're not sure which files belong to which project, you can just open that up in Notepad and use that to have a look. There are a couple of questions, 2 or 3 actually, about upgrading projects. So there's one question here about having an IDE add-on or perhaps some other upgrade system that would open the very old project formats or something like that. and perhaps just take the very core information, such as which files were in there, and create a new project from that. And that's a really good idea. So we don't have that currently, but it's fantastic feedback. And yeah, we'll take that into account. There's a question about exactly what I meant when I said creating a new project and adding your files. Does that include the CPP, the .h, and the DFM files for forms in the old projects? So theoretically, if you just drag in the .cpp files, then it should recognize the attached form and header. So if you drag those in from Explorer, then you should find that the nodes that are created in the projects view will automatically include the matching header or the matching form file. If for whatever reason that doesn't occur, then yes, you could drag in the others. But in theory, it should pick that up. And a related question is about when you have a project, the example here is drag and drop won't work effectively if you consider a project with 200 units, but they're inside 40 or 50 different folders or subfolders. And yes, that's an excellent point, because if you have 40 or 50 different folders with source in, and trying to drag drop into a project, that's quite a lot of work to do that 40 times. The best thing I can think of there is to use Explorer to search. You can search for star.cpp, for example, to find all of the units and then drag them in all at once. Although it's not ideal, and I actually don't know whether this would match your particular layout. Let's see. There are a couple of questions about an app that doesn't use OWL or the VCL, but just uses pure Win32, so the pure Win32 API, Windows messages, that kind of thing. And in fact, one about an app that's written in pure C code. And that kind of thing should be very straightforward to port forward. It should, obviously ideally, and the real world isn't exactly like this, but it should be fairly close to being able to sort of open the source and rebuild straight away. That said, though, something that was built using pure the Win32 API 15 years ago probably still uses the ANSI APIs and ANSI strings, and you may want to upgrade to the Unicode APIs. But that kind of application should be very easy to rebuild. There's another question about how to migrate to a later version or to Clang if there are hundreds of project files. And do we have any plans to create some migration tools? And this is related to the question from a couple of minutes ago. Look, that's a really good point. And hundreds of project files is going to be difficult. Right now, we don't have a solid answer for that because, as you can tell, I recommended manually creating a new project and adding your source files. And if you have hundreds of project files, then that's quite a bit of manual work to do. So just as with the previous question about adding some sort of light upgrade functionality, that is something that we should definitely consider. What I'd be really interested in, if this affects you, if you have that kind of problem, is to send me an email, please. It's really useful for me to see the exact kind of problems that you have. To see how many project files you have and when they were built and with what version and that kind of thing. And that kind of thing is really useful to know. So yeah, please drop me an email. Let's see. There's a question about ActiveX. So older projects often use ATL, which is a part of the installation, and where can we get it today? So today in C++ Builder, we recommend using COM using what we call DAX, which is the DollFree ActiveX system. We no longer ship ATL, which is the active template library. What our documentation suggests there is simply to copy the files from an older version of C++ Builder. there is a library file that a follow-up question pointed out that, that might also cause a problem. So for the pure templates, for the pure headers, that should be okay. If you're using some of the binaries, that might be a bit more tricky. I would recommend if you're using ATL, just first of all, just try with the headers. But if you are actually linking in some of the binaries, then send me an email into what we can do to assist. Let's see. There's a question about creating UTF-8 source files. So the IDE currently doesn't expose this setting, but it can be set to automatically create UTF-8 source files. Alan Bauer blogged about this back in about 2011 or so, I think. And in the Q&A, I posted a link to that. But if you Google for something like Alan Bauer, DollFree UTF-8 unit or something like that, you should also be able to find it. There's a question about why Unicode string is a UTF-16 string, or why didn't we choose to use UTF-8 as the default for DollFree? Well, there are a couple of things there. First of all, Unicode string is usually UTF-16, but it could be using a different size character as well. So if you open ustring.h, you'll see a couple of ifdefs there for, let's see, there you go. There's an if defined wide car is wcar. And so Unicode string can actually be using a car 16 or car 32. Let's see, I hope I have that right. This is from memory. And yeah, so anyway, UTF-16 is because Windows is UTF-16. And when we moved DollFree and C++ Builder back in 2009 to use Unicode, one of the things that we've always tried to do is to have platform native behavior. And so if we chose UTF-8 as the Unicode string, then we'd be translating to UTF-16 with every interaction with the Windows API that takes a string, which is a lot of overhead. Ideally, what we aim to do is have a native Unicode string on each platform. So we do have a UTF-8 string type. That's simply UTF-8 string. And you can easily convert that to and from a Unicode string if you want. So hopefully there you have the best of both worlds. Related question about switching to Unicode, if it's better to choose UTF-8. So far Windows is the target only, but later maybe Linux as well. So we haven't released C++ for Linux yet. So I can't give a firm answer about what a C++ string will look like on Linux right now. What I would recommend though is that you use the inbuilt native Unicode type. What you may want to do is use the _t bracket macro for strings, because that will give you whatever tcar is defined as, and then when you rebuild whatever it turns out to be on whatever platform, that should be fine. Let's see. There's a question about recompiling a 10.2 project into 10.3 and wondering what the main differences are. So assuming that's for Win32 Clang, for Win32 Classic, it should be much the same, but for Win32 Clang, we have an updated compiler. So it now supports C++ 14 and C++ 17. We have a new version of the standard library, the Dinkerware STL. We have updated our RTL with a whole bunch of missing methods, a whole bunch of things like that. If you have any issues recompiling 10.2 to 10.3, then most likely where those are would be a compiler issue, for example. We released a hotfix against 10.3, and then we released a whole bunch of other quality fixes in 10.3.1. And since we've done that, we found that there should be really good compatibility. I'm aware of actually only one bug which which we obviously want to address. I mean, there can be more bugs, but one bug that is potentially important, and that doesn't affect the vast majority of users. So if you're using 10.3.1, most likely you should find it just a straightforward recompile from 10.2 to 10.3. There's a comment here from someone: I only use string, so capital S, the DollFree string for the UI. Everything internal to my app is to W string. That sounds perfect. You can convert to and from those two using CStr. And also, I see there's another reply here pointing out the underscore tcar maps to option, which is also something that's well worth being aware of when you create a project, or if you happen to upgrade a project. That's one of the key settings. You want the tcar maps to option to be set to wcart for modern projects. Let's see, I'm only about halfway through here. Mary, have you seen any questions that you would like to answer?
I'd like to make a comment. Someone mentioned a few times the Delphi parser, the product that'll like do a Unicode migration for you. Thank you for that sort of link. I went ahead and Googled it. It's actually pretty cool. If it does exactly what it says, it'll do the entire migration for you, basically. So that's pretty cool. So that one I saw, but otherwise, most of the questions have pretty much, at least that I'm seeing so far, have been answered. So far, I'm not seeing anything.
So I will pull the question log after the webinar is over, and we can go through and make sure all the answers are correct and put them on a blog post on Community that with the slides and the replay. So everybody can look forward to that as well. It'll be on the community site that David shared, which I'll put in the chat window here again as well.
Well, fantastic. Thanks for that.
All right. Well,
sorry, Mary, go ahead.
Oh, no, I was just going to say there's one question someone asked about that we mentioned that there was a lot of information from switching to Win32 to Win64. We have a lot of things on our YouTube site beyond just Al's presentation and webinar that he did. So, I mean, we've got some by some other product engineers that specifically work on C++ Builder. And you can just kind of go to our Embarcadero YouTube channel and find a lot of those links, and they'll have additional links as well within those. So that'll be a great resource for you as well.
Fantastic. Yeah, we have. I was really surprised. I looked it up yesterday. It was, I don't remember the exact number I put in the slides, but over 1,500 videos on YouTube.
Mm-hmm.
Yeah, there's a lot of resources there. And the DollFree parser is a really good point as well. I haven't tried that myself. I'm really glad to hear it's useful.
Mm-hmm.
I'm going to go through and try and finish the second half fairly quickly, since we still have a lot of people online and a lot of questions. There's another question here relating to how to write strings. Honestly, there are a whole lot of different string prefixes, I suppose, ways to specify what format a string is in memory. And I did a quick talk on this, but there's plenty of material out there. A lot of this really depends on whether you want strings that you type in the code editor to be able to float between different types, to potentially be both an ANSI string and a Unicode string. You may want to just use the L prefix, so L double quote, for a wide string, or you might want to use the _T bracket macro. If you're unsure, then _T is probably the right thing to do. There's a question about targeting Win64. Should we write C++11 compatible code if we want to target Win64 in the future? And when can we expect C++17 for Win64? So right now, at the time of this webinar, we have C++17 for Win32, but not yet for Win64. So today, which is in March 2019, if you want to target both, then you should target C++11. But obviously, we plan to get Win64 out supporting C++17 soon. So unfortunately, we don't do something like promise a particular release ahead of time, just in case. We don't want to make promises like that. But Win64 is obviously very important to us. We want to have all of Windows supporting C++17. So hopefully we'll have a different answer to that question fairly soon. So the question is about the speed of Clang versus Classic. So the Clang compiler is slower than the Classic compiler. It's because it does a lot more. It understands a lot more and very different C++. And it does a lot more code optimization and that kind of thing as well. But it should not be hugely slower. So if you're seeing code compiling with Clang that's, let's say, 4 times slower than Classic or something like that, that is obviously not good and isn't what you should be seeing. So there are a few things there. Apart from sort of trying the obvious things like precompiled headers and that kind of thing, if you have a very similar setup between Classic and Clang and the compiler options are set up correctly and that kind of thing, and you're still seeing the performance impact, what's most likely there is that there may be a particular code pattern that's causing some slow compilation. So every so often someone files a quality report with us and says, this code here, this specific code really slows down the Clang compiler. And when we get that, we go and fix it. So if you've tried Clang in, say, 10.2 and you saw it was slower, it might actually be a lot faster for you now because we've fixed quite a few of those things in 10.3 and 10.3.1. But there may still be code, or there might be even, let's say, so the problem with this is that it can be very specific. So there might be particular headers that you've written that have particular code structure that for whatever reason happen to cause Clang to be slower. And the only way we can solve this is by seeing that specific code and addressing any particular issue that brings up. So if you're seeing a significantly slower Clang, and not just in general with particular code, please put that code in a quality report, or if you don't want it to be in public on Quality Portal, then you can send it via filing a support request. We'd find that really useful because we can run that code through the compiler and we can figure out what's making it slow. There's a question here about warning about using try and underscore finally in Clang. So I'm actually not completely certain what that question was referring to. So if that was you, feel free to write another question, please. But possibly what it means is that mixing try without underscores, so try catch, and underscore try underscore finally is dangerous. So you shouldn't really mix those, as in to have try and underscore finally. The reason is that they're meant as different pairs of code constructs. So try catch and try underscore finally are 2 separate sets of things to do with different exceptions. So that's a really good point, and thank you for that question. That's definitely a code style or safety thing that it's worth pointing out. There's a question here. I must admit that Clang pointed me to errors, almost all simple to fix, and made my code better. Well, that's really good to hear. Clang does have, it is stricter on the C++ standard, and it does have excellent error messages, and your code will end up higher quality when you build it with Clang. There's a question about when I use the word straightforward for something, whether that always is straightforward. And of course, sometimes, realistically, it won't be. There will be issues. It's difficult in a presentation like this, which is necessarily very generic, to delve into particular issues. But when I've used a phrase like straightforward, hopefully in general it really is. It doesn't mean that there's no work, but that it should be hopefully work that can be is reasonable to attempt. But of course, it's very difficult to say that without knowing your actual code. In general, though, that's just a recommendation, what it's likely to be and what you should hopefully expect. This particular question here reports about a bug where Clang didn't calculate the size or offset of an extended. And so when migrating to Clang, the Clang migration was not straightforward because of that issue. And so that's an excellent point. And first of all, my apologies for that particular bug. And I know we've fixed bugs in that area, so hopefully if you try 10.3.1, that particular bug should be gone. There is always the danger of encountering a bug like that or an issue, but we keep on fixing things. In 10.3 and 10.3.1, we have solved so many issues, and we're getting a lot of feedback from people that it is now a lot easier to migrate from Classic to Clang than it used to be. So, for what it's worth, that is the feedback that we're getting, and I hope that it would be true for everyone listening to this as well. And of course, if you do it and you find problems, let us know. I mean, this is the kind of thing that we want to fix and want to assist you with. Let's see. I think there are a number of questions here that I've been speaking rather than being able to reply via text. Let's just have a quick look at those. There's a question here about the slides and links. Yes, so they'll be in the chat. I think Jim put them in the chat, but they'll be made available, and there'll also be a replay on YouTube. There's a recommendation here to check out TMS. They're a tech partner. They make great components. They have a set of components called FNC, which are they work both between the VCL and FMX, which is really nice thing. So yes, that's a great recommendation. Let's see. Is it possible to link Clang-built binaries with libraries built by the Classic compiler and vice versa? We're trying to migrate to the Clang compiler mode. We've encountered an issue when linking an executable built with the Classic compiler with the Clang-built library. There were some issues. So that's an excellent question, and the answer is no. When the Clang and the Classic compilers use different versions of C++, they use different versions of the STL. They have different ABIs, so they are not compatible in terms of linking them together. You should always only link binaries created by Clang together or binaries created by Classic together. It's potentially a little bit confusing because both the Classic compiler and the Clang compiler are compatible with the DollFree compiler. It's just that they're not compatible with each other. And so if you mix a binary, whether that's an object file or something else, a library or something like that, built with the two C++ compilers, Classic and Clang, you will encounter linking errors. If by whatever chance you were lucky enough not to encounter a linking error, you would absolutely encounter runtime errors because you'll be linking different standard libraries and different ways of calling methods and that kind of thing together. So please only link Clang with Clang and Classic with Classic. There's a question here about a project dependency of ACE. So ACE Tau is a really common library. We're actually looking right now at what we can do to ensure that specific library is compatible with our Clang compiler. So hopefully we'll have some news for you soon. And if you ask that question or you use ACE, please send me an email. We should have some news for you soon. Will Boost support include the results of the Boost regression tests? Oh, look, that's a really good question. We're looking at those results right now. This is how we're making the assessment of whether we can release Boost or not. And I think publishing those would be an excellent idea. So we should definitely do that, yes. There's a question about guidelines for migrating a TurboVision C++ project. So TurboVision does go back quite a way. This is going to be a bit off the cuff here, but the UE library you're most likely using there is probably technically not even a UE library at all. It'll be your TurboVision being a command line. So it's the wrong term exactly, but a console UE. I don't personally have experience upgrading that to a visual UE. I think I would approach that by trying to break it down by separating the user interaction with the business logic. That business logic would be written in very old C++, but it should ideally be reasonable to port forward because C++ has pretty good backwards compatibility there. And you would obviously need to redo the UE completely. But that's really high level advice. I'm not certain it's concrete and useful advice because it depends here on splitting apart the TurboVision part, the bit that was the console UE, and ensuring that you can still take your business logic, the app logic forward, and that depends hugely on how the app was actually written in the first place. Maybe you could drop me an email about that, send through some code snippets, and I could give some more sort of concrete advice based on seeing the actual code. But I'm really glad to hear that a project's written in TurboVision, that you're considering moving that to 10.3. I think that's fantastic. There's a question, are there any issues if you use ANSI string as a transport container to move UTF-8 content? Yes and no. We wouldn't really recommend it. So ANSI string today in 10.3 and has for a few versions it can be templatized to carry a code page. And this is really useful if you have an app, for example, that was using any particular ANSI code page and you want to have data or data that you load from an old file, for example, and you want that to correctly convert to Unicode. You can codify the specific code page that your ANSI data was in and then convert it to Unicode, and that will convert correctly. Now, we have UTF-8 and we have a UTF-8 string, and that's what we would recommend for carrying UTF-8 content. Technically, that's actually implemented with a particular pseudo code page. So if you use that same pseudo code page for ANSI string, you would be doing the equivalent thing. But really, I think it would be better to use the UTF-8 string itself in code, mostly because that also carries information for the developer. When a developer comes back and reads this in a year and they have a question, what kind of payload does the string carry? It's going to be very obvious that it's UTF-8 if it's in a UTF-8 string. So I would strongly recommend that. Also, you're far more guaranteed to have correct behavior if you do that, rather than trying to ensure that you happen to use an ANSI string templated with the right code page there. Let's see. O'Brien commented, character-oriented windowing library is what TurboVision is. That's a fantastic term. I was trying to struggle and describe it as a console UI or something. Thanks, Brian. Character-oriented windowing. That's fantastic to have the right term pointed out. Look, I've reached the end of the questions here, and I have missed quite a few. I know we have several hundred here, and I want to thank everyone for the attention you've paid to this and for the number of questions. It's fantastic. Mary or Jim, have you seen any key questions that I've missed that either of you would like to reply to?
Let's see here. I answered a couple of questions. There was one about migrating from recompiling Win32 to Win64, another one about data modules. I said Win32 to 64 is typically pretty straightforward unless you're assuming the size of a pointer, but I wasn't sure about data modules. Do you have any advice on data modules, or if you answered that, I missed your answer?
I didn't answer that. I'm actually not certain what problems with data modules there would be, because a data module should just open. Unless it refers perhaps to using very old database technology. And actually, Jim, you probably know more about that than I do.
Yeah, if you're using a BDE, then you can use Refind. I know DollFree Parser also has functionality around that, but you can use that to convert it. In the past, I've actually written, long ago, I was converting from BDE to, I think it was Asta, which is a thin client library similar to DataSnap, and I wrote a component that you could just drop on the form. It would iterate through all the other components of the form. If it was a BDE component, and replace it with the appropriate component. So that's not terribly complicated to do if you want to do something with OpenTools API as well. But Refind is the recommended way to go for that if you want to migrate from BDE to FireDAC. And if you're not on FireDAC yet, if you're still using BDE, FireDAC is so much better. Oh my goodness. I've been a long time DollFree developer, and BDE was pretty cool, but had some issues. And then since BDE, there was lots of things that weren't quite as good, but FireDAC is just amazing, even compared to all the third-party tools I've used. I love BDE, or FireDAC, sorry. So definitely check it out if you're not using FireDAC yet.
Thanks, Jim. Mary, was there anything that that you saw that you'd like to answer?
No, like I said, just kind of made the comments that, like that Jim was saying beforehand, FireDAC is definitely the way to go. It's fast and it has everything you need. But that's pretty much about it.
I could spend hours just talking about how much I love FireDAC, honestly. There's a set of FireDAC skill sprints. You can check those out. Refind, I think we have webinars around using Refind, REEFIND, to migrate from BDE to FireDAC. Carrie Jensen just wrote a book on FireDAC, DollFree In-Depth FireDAC, which I would definitely recommend checking out. Carrie Jensen is a phenomenal author and does everything amazing. Everything he does is just amazing. And yeah, so it was interesting actually, because when we first, there's a little inside baseball story, I guess, but when we first released FireDAC, I went to Carrie. I said, "Hey, it'd be great if you could cover FireDAC." And I'm not really familiar with it yet, and I wouldn't be comfortable talking about it until I'm really familiar with it. I'm like, "Oh, okay, that's too bad." And it's kind of bummed. And then later he gets back to me. He's like, "Oh, I was doing this consulting for this client, and they were using an old version of FireDAC." And I said, "Well, let's try the new version of FireDAC and see if that fixes these issues you're having with performance and just drop database connections and a number of other odd things." He said, "That's just an easy thing to check." And so he upgraded him to the latest version of FireDAC, and he was blown away by the performance improvements. And so now he just tells everybody, upgrade to FireDAC, the latest version of FireDAC, and then we'll talk. Because if you're not using the latest version of FireDAC, you're going to have troubles. You're doing it the wrong way. You're going to have a bad time. So use the latest version of FireDAC, and then if you still need help, he'll help you out. But so he's become a big fan of it since then, which I'm very excited about.
All right. Well, thanks for that. And
so Oren has commented here. Sorry, about the he's the author of the DollFree Parser. He says 4 years ago I migrated a database-oriented system in C++ Builder 3 to XE4 with ADO. So that's useful to know. So if you have questions about Delphi Parser, Oren is the guy to talk to. He's the author behind that.
Fantastic. Well, the webinar's been going for an hour and 50 minutes now, and I think we've answered the majority of questions, or at least the majority of topic areas. So thank you all for attending, and thank you for the interest and the questions. I do want to ask as well, please feel free to get in touch anytime. I don't think my email's on screen, but it's david.millington@embarcadero.com. It's always good to hear from you, and the kind of issues that you have, if you have some, or success stories, of course, all that kind of thing, or even just to know what you're doing and what you're using Seaborder for. It's always fantastic to get an email from someone. Jim and Mary, thanks very much for being on the Q&A here. Really appreciate it.
Thank you.
I think with that, we'll probably draw it to a close. Thanks very much.